Okay, I've got my test set up for this. That's the Aukee super bright 15,000 lumen crazy LED headlight in there. I've got it hooked up to a power supply, and I'm using multiple leads just to make sure the voltage drop is not significant. Um, so I've got it set to 14 volts, the output's off, and the current is limited to 5 amps. That doesn't mean it's going to give it 5 amps, but we can see what it takes here. So we'll turn it on when it's cold, and we'll watch the output voltage should go to 14 volts, and then the current should tell it what it's doing. And you can see the current going, 3.2, 3.19. So it starts drawing a little less current over time, but it's basically 3.16 amps at 14 volts. Which 3.16 times 14 is 42.24 watts. So I'm going to do a sweep on this and get a curve, but just for comparison, let's do the same thing with the halogen light. Okay, I've got basically the same setup here with the halogen light and 14 volts. Sorry for the janky setup. I usually do really low current electronics, so all I have is these skinny test leads, so I'm just hooking a bunch of them out to keep the drop down. All right, I'm going to move the light out of the way here, and we'll watch the current on this halogen light. I expect the current to be very high. It might even go constant current at 5 amps when you first turn it on until the filament heats up, then I expect it to drop. So let's take a look and see what it does. So yeah, you saw it constant current there for a little bit, and then it's 4.42. Okay, I'm going to go do the math for 14 volts and 4.42 amps. Okay, so 14 volts and 4.42 amps is 62 watts. So your 55 watt halogen running at 14 volts is quite a bit more. Now, to be clear or to be straightforward or whatever, the voltage at the actual headlight terminals, like at idle, was only like 11. So maybe this is closer to 12 by the time you put the drop in the ProMaster. So if do vset 12, enter, and let me see here. So that gives us 12 volts at 4 amps. So, we can do that math in our head. That's 48 watts. So basically you can change the wattage by changing the voltage of these halogen bulbs. All right, so we'll do a quick sweep and we'll see what happens here. And okay, so here we're doing a sweep. We've got the halogen bulb going there, and then you see we're at 8 volts. It'll pause there for a while, take a few readings. And crap, something's broken. This is a test script that I adapted from some other crazy a test script that's designed to check LCDs. So anyway, just give it a really quick hack. Anyway, give it a little more settling time, and now you can see it's moving up the voltage, 8.5, 8.6. And as it's moving up the voltage, it'll record the voltage and record the voltage. So, or record the current. So what I'll be able to do is get a chart that shows the voltage versus current for that halogen light. So we'll let that run, and then we'll repeat that with the LED light. Okay, the sweep was supposed to go to 14, and you saw it just finish up there. So we'll reset the sweep and do it with the Aukee halogen one. See what happens. Okay, at 8 volts, it's noticeably dimmer than normal, and you can see every step up in voltage, it gets a little brighter. Which, that's expected. You don't expect to have full brightness at 8 volts. So 8.4, 8.5 volts. Again, kind of sorry for this janky setup. I just used 3 leads to minimize the voltage drop between the meter and the headlight terminals. This other power supply I have, it has remote sense on it. So those yellow wire sense down, but this only goes up to 3 amps, and so I had to use this top supply that I haven't modified yet, and it goes up to 5 amps. So we'll let that sweep run, and then we'll take a look at the data. Okay, we've progressed along the sweeper a little ways, and you can see the LED is doing its I'm a very bright light thing. So we're at 12.8 volts and 2.8 current there. And then what you'll notice is now we're at 12.9 and the current's going down 13 volts. Now we're at 2.75. So basically this is typical of a constant current LED driver, which I believe the headlights have in what people call the ballast box. It's not a ballast, it's a constant current LED driver. So what that's doing is it's keeping the current in the LED correct at their rated current. So as we feed it more voltage, it consumes less current coming in because the amount of current it's putting out into the LED is the same. So the chart will show this, and okay, that was the end of the sweep. Got up to our 14.9 or 15 volts or whatever it was. Oh, 13.95 went up to 14 volts. All right, so I'll stick this in a spreadsheet and we'll see what the curves look like. Okay, welcome to Crappy Videos 101. So this, so we got the data from the meter, basically the voltage coming down in your x-axis here, and you get your halogen current, halogen power calculated from the current and the voltage, LED current and the LED current calculated from the LED current, or the LED power calculated from the LED current and the voltage. And here is our chart. So left edge is 8 volts, right edge is 14 volts. Now I was in the ProMaster, I was seeing a few volts drop between the system voltage and the LED and the headlight. So that's why I didn't go to a full like 14.8 or whatever. 14.4 is typically what I see on my battery voltage, but I don't think the headlights themselves see that, but that's just for comparison. So as expected, the blue line is the halogen current. That's this line on this scale. So the halogen current tops out at about 4.4 amps. And the orange line is the halogen power. So the halogen power starts down here at 26 watts, ends up here at oh, maybe that, get that out of the line. Never going to choose it. Okay, so the halogen, well, we can see it over here. Halogen power starts at like 25.9, so 26 watts, goes up to 61 watts. And the halogen, both the power, which is the orange here, and the blue, which is the current, the orange is on this axis over here. You can see it ends something over 60 watts, and the blue is the current, about 4.5 amps. So for the halogen, nice line, things of resistor, pretty much what we expected. Now, the LEDs are more interesting. I did not expect them to peak here, so the LED current peaks at 4.23 amps at 10.7 volts. And the LED power peaks at 46 watts at 10.7 volts. Now, I guess it kind of makes sense. So basically down here, it's not in this constant current section, in this rising section. So once it gets up to 10.7, it's outputting its full brightness. And then as you give it more voltage, it doesn't need quite as much current. Okay, so so looking over here at the chart, so starting at 10.7, that's this one. So at 10.7, the LED current, that's when it first starts going. The LED current goes from 4.3 down to 2.5 amps. And the LED power goes from 46 watts and drops down to 35. So maybe that's what's going on, is that the computer in the ProMaster thinks that since this power, the yellow line from the LED is so much less than the power of the halogen, that it thinks it's disconnected. I don't know why it would shut that off. That logic doesn't make sense, that the computer would shut it off, but maybe that's what's going on. So I guess what I'll do is I'll figure out what resistor should make up for this distance here, and jam that in, or buy a ballast or whatever they want to call it, their CAN bus buffer resistor, or whatever crazy name they put on a resistive element, and see if that makes them keep on. Interestingly, even though in that other video they shut off multiple times after a trip, this morning just run it in the barn, even at high idle for like 2 or 3 minutes, they would never blink off. So I don't know if running at highway speeds or maybe vibration. I don't know. I still don't understand why this thing's shutting off. Anyway, so there's a bunch of data. I'll throw this spreadsheet up on the forum just for you guys if you're geeky enough to want to look at it. Thanks for watching.